Hi class, let's continue our discussion in topic 1 electrostatic with the subtopic 1.2 electric field. Before that, let me introduce to you the learning outcome for this subtopic 1.2 electric field. Part A, define and use electric field strength. E equals to the F per Q naught. B, use E equals to KQ over R square for point charge. C, sketch the electric field strength diagram. Simple configuration of charge with a maximum of 4 charge in 2D. And D, determine the electric field strength E for a system of charge. Again, simple configuration of charge with a maximum of 4 charge in 2D. So first, let's look the definition of electric field. Okay, in the sum the other way, we are going to define the electric field strength. Electric field or electric field strength is a region of space around isolated charge where an electric force is experienced if a positive test charge placed in the region. Electric field strength E is the electric force per unit positive charge that act at that point in the same direction as the force. From the definition here, we can write the formula of the electric field strength. E equals to the F per Q naught. Okay, where F is the electric force and Q naught is a positive test charge. Now let's look at the derived formula. As we learned before in subtopic 1.1, we have the electric force F equals KQ naught over R square. And we know that E equals to F per Q naught. Okay, we substitute the F inside the equation of the E. So you are going to get E equals to the KQ naught over R square per Q naught. Okay, so we can cancel it out, the Q naught with the Q naught. Okay, we simplify the equation. So we get the final equation is E equals to the KQ per R square. Okay, so you are going to apply this formula in your calculation later. Okay, the unit for the electric field strength is Newton per Coulomb, or we also can use volt per meter. The quantity for the electric field strength, it is a vector quantity. So it must have magnitude and direction. Okay, we go back to the formula just now. Okay, from the equation of E equals to KQ per R square. Okay, each of the parameter will give you, E is a electric field strength. Okay, Q here is a magnitude of charge. Okay, R is referred to the distance between a point and point charge. And K is a Coulomb's constant where the value is 9.0 times 10 power of 9 Newton meter per second. Let's discuss the example of the electric field strength. So here I have example of the direction of electric field strength at point P. Let's discuss example number 1. In this example, I have a point charge which is a positive point charge. So this is my point P. So if you want to show the direction of electric field strength at point P, you need to put the test charge at point P. So this is my test charge. Okay, and our test charge, it must be positive test charge. So in our syllabus, we are only consider for the positive test charge only. So now I will locate the positive test charge at point P. Okay, so now between the point charge and test charge, again, it still have the force. Okay, since our test charge is positive and our point charge is positive, so you are going to get the force between these two charges on the test charge is a repulsive force. So we can show the direction of the repulsive force. Okay, on the test charge, you are going to get the force is a repulsive force and direction is to the right. So we can label here, this is our force F acting on the test charge. Okay, so now for the electric field strength, okay, you are going to get the direction of the electric field strength on the test charge is also to the right. Okay, so I can put here the label of the electric field strength as E. Okay, so now you are going to get the direction of the electric force and direction of the electric field are in the same direction. Okay class, so we can refer back to the definition of electric field strength E, where the electric force per unit positive charge that act at that point in the same direction as the force. Okay, actually here I want you to make some of additional information. Okay, should be the definition of the electric field strength E is the electric force per unit positive test charge. So at this charge, I want you to put it as a test charge. Okay, you have the positive test charge. Okay, so at the point where you locate the test charge, okay, you can determine the direction of the electric force and also the direction of the electric field strength. Okay, so here you are going to get direction of the electric force and direction of the electric field strength are in the same direction. Next, I'm going to discuss with you the example of number 2. Okay, in this example, I have the negative point charge. And this is my point P. Okay, so if you want to show the direction of the electric field strength at the point P, okay, so I will put a positive test charge, okay, at point P. So here I will take this positive test charge and locate it at point P. Okay, so now I have my point charge is a negative charge and my test charge is a positive charge. Okay, so now again between the point charge and the test charge, it still have a force. Okay, since we have the sign for these two charges are in a opposite sign. Therefore, on the test charge itself, you will get that there is an attractive force exerted on the test charge which locate at point P. So we can show direction of the force F, okay, which is to the left. So you will get that our positive test charge will be attracted to the negative point charge. So I label here, this is my force F. Okay, again, for the direction of the electric field strength, you are going to get direction of the electric field strength is the same direction as the force. Okay, means that we are going back to the definition of the electric field strength. Okay, where you have, okay, the electric force per unit positive test charge that act at that point is in the same direction as the force. Okay, so we show that, okay, I'm going to show to you that the direction of the electric field strength is in the same direction as the electric force. Okay, you can label here, this is the electric field strength E. Okay class, so example number 1 and number 2, this is the example where we have, okay, the single point charge. Okay, where we have the point P, and at the point P, you are going to locate the positive test charge. Okay, now let's move to the example number 3. Okay, for the example number 3, I have 2-point charge. Okay, so label as Q1. Okay, is a positive point charge. Label as Q2. This is a negative point charge. Okay, where is my point P? Okay, my point P, I locate it, okay, in the between of point charge Q1 and point charge Q2. Okay, so now we need to show the direction of the electric field strength at point P. Okay, so what are we going to do is, I will put my positive test charge at point P. Okay, you just take a positive test charge and locate it at point P. Okay, I label it as Q0. Okay, so this Q0 is referred to the positive test charge. Okay, so now you need to show direction of the E. Okay, first of all, you can show direction of the electric force first. Okay, so you do at point P, okay, you have the positive test charge, okay, by Q1. Okay, so Q1 is also positive charge. Okay, so positive and positive charge, you akan dapat apa? Repulsive force. Okay, so kamu akan dapat arah bagi electric force is to the right. Okay, so on the positive test charge, dia akan repel lah. Ini F-nya. Okay, saya label lah sini F1 ya. Okay, now dekat sebelah kanan, okay, at the right side, you have the negative point charge. Okay, again, you need to compare between the point charge of Q2 with the Q0. Okay, so on the Q0, you will get that there is an attractive force. Okay, means that our test charge here will be attract to the negative point charge. So I label here, this is my F2. Okay, this is direction of the force. Okay, but now we need to show the direction of the electric field strength. Okay, so our direction of the electric field strength actually is same as the direction of the force. Okay, so I show to you by using the other color, ya. Okay, I use the purple color. Okay, so you akan dapat arah electric field on the test charge by Q1 is to the right. Okay, this is the E1. Okay, and the direction of the electric field strength on the test charge by Q2 is also to the right. Okay, this is a E2. Okay, so now at point P here, okay, we have two electric field strength, okay, acting on point P. So in the calculation later, you are going to calculate what is the magnitude of E1 and what is the magnitude of E2 by using this equation, which is E equals to the KQ per R square. Okay, you need to do the calculation, okay, one by one. Okay, next, you are going to find out what is the resultant or total electric field strength at point P. Okay, by using the equation of electric field strength, okay, at point P equals to the E1 plus E2. Okay, this is the example of number 3. Okay, the same thing goes for example number 4. Okay, this example, I have 2-point charge Q1, a positive point charge. Q2 is also positive point charge. Okay, here is my point P. Okay, this point P, I locate it in the middle of the Q1 and Q2. Okay, to show the direction of the electric field strength at point P, I will put a positive test charge at point P. Okay, you just draw this is a positive test charge, okay, at point P. So we label it as a Q0. Okay, first of all, we can determine the direction of the electric force, okay, that acting on test charge or at the point P. Okay, so on the test charge by Q1, okay, you have positive and positive. Means that on the test charge, you will get that there is a repulsive force F. Okay, so I label here, this is the F1. Okay, next, at the right side, again, you have the point charge of Q2. Okay, now you need to show direction of the electric force acting on the test charge by Q2. Okay, so again we have point charge is positive and our test charge is also positive. So you will get there is an repulsive force acted on point P or on the positive test charge. So kita akan dapat arah dayanya ke kiri. So I label here, this is the F2. Okay, settle for the direction of the electric force. Okay, now we need to show the direction of the electric field strength at point P. Okay, to show direction of the electric field strength, you just follow the direction of the force just now. So I will get, okay, on test charge by Q1, the direction of electric field is to the right. Okay, I label here, this is the E1. Okay, because direction of the electric field strength is the same as direction of the electric force. Okay, kamu ikut je arah electric force tadi, ya. Okay, yang ni by Q1. Okay, next, the direction of the electric field strength, okay, on the test charge by Q2. Okay, yang ni pun kamu ikut je arah F2 ni. So you are going to get direction of the electric field strength on the test charge is to the left. Okay, we label here as the E2. Okey, ini arah ya, ini arah ya. So kalau kamu nak cari magnitude of E1 and E2, okay, you can apply the equation of E equals to the KQ over R square. Okay, you need to do the separated calculation. Okay, means that on the point P here, we have two electric field strength. And you need to come up with the net electric field strength or the total of electric field strength. Again, to find out the total or the resultant or the net electric field strength at the point P, okay, we just apply the equation of E1 plus E.